All right, so we're going to go back and deal with long division and the importance of long division and teaching estimation with long division. All right, so let's begin with, of course, division is an important part of intermediate math. And so let's go through, first of all, the importance of long division. The importance of long division. Long division is necessary for whole number math, decimal math, percent math. A big portion then of arithmetic. So division is one of the 4 basic operations of arithmetic, and long division is done frequently. It is a frequent part of application problems as well. And where we start having trouble with long division is when the divisor becomes 3 digits or more, the dividend becomes 5, 6, 7, 8 digits, and then we get further into trouble when we add the decimal point and so forth. And of course, with our percent math that we've been covering, 2/3 of the problems will be done by long division. And long division has a bad reputation, and deservedly so, because it can be tedious and time-consuming. But the biggest problem with long division is students rely too much on trial and error. They don't understand estimation. So long division is a big part of intermediate math. The second thing, as far as the importance goes, of division, we're dealing with intermediate math, and long division takes off in the 5th grade. Okay, so long division is something that must be taught and addressed and practiced in the 5th grade. So it is a big part of arithmetic, and it is a big part of intermediate level arithmetic. It really takes off in the 5th grade. They will be doing larger long division problems with whole numbers. They will be doing division with fractions, and then they will be starting to do decimal division. All right, so what is the problem with division? What's the big deal with division? Why is everyone's least favorite, well, maybe not least, second to story problems, everyone's least favorite section is divide and check? Okay, if you grew up with the Abeka curriculums in 5th and 6th grade, in 7th grade, you hated the divide and checks, because no matter how hard you tried, the check never matched the dividend. So let's talk about long division and now teaching long division in intermediate math. The whole crux of being able to do long division is the estimation part. All right, so what we need to do is we've got to teach students how to estimate. And the first thing that I want to stress is that estimation is not guessing. Estimation is just that. It's estimating. It's not guessing. It's thinking through ahead of time and anticipating what the answer is going to be. So it's more of an anticipation and thinking something through ahead of time to get an approximation. So estimation is approximation. Estimation is having a sense of where the answer is going to fall. It is not guessing. It is not random. And so we have to ourselves understand long division enough to do it effectively and then to be able to teach it. All right, so estimation is something that must be taught. So what we want to do to teach estimation is we want to establish guidelines of an efficient way to estimate. And then the second thing that we're going to do is we're going to help the students learn how to think. So estimation involves thinking ahead of time. Estimation does not have rote procedure steps, and that's why students don't like it. All right, I can give you some guidelines. I can give you even some type of a flow chart to help you think through estimation, but there's no hard and fast estimation steps. because it involves thinking through the problem. It involves evaluating what the divisor is, evaluating what the dividend is. And so it is a thinking process. So estimation is something that must be taught. So what I'm going to do is I'm going to help them think through problems by showing my own thought process, by teaching them to ask themselves certain questions. So there's not a set of steps that say, do this, do this, do this, do this. Thinking is involved, okay? And so students tend to be mentally lazy and they dislike long division because of the thought process involved in the estimation. So if you remember, the steps of long division are to estimate, then divide, then multiply, then subtract, then compare, then bring down. And so the estimation is the first step that we're going to get hung up on. So let's go through some guidelines and things that you do as you're thinking through your estimation step. What is the quotient going to be? And we also do not want to waste time on quotients that are not plausible. So the whole idea here is we're thinking through ahead of time. What is a plausible quotient? Not random guess. Guessing is not a math skill. Estimation is not guessing. Estimation is anticipating where the quotient, in the case of division, is going to lie. And so we need to practice long division. And if we practice the estimation step, the rest of the problem, the rest of the steps, the rest of the procedure, dividing, multiplying, subtracting, and so forth, can be a problem when careless mistakes are made, but many times students don't even get started because they can't estimate. So, guidelines for estimation. First of all, estimation only starts with the rounding rules. Now let's think about long division. Once we start going with a two-digit divisor and we're getting beyond our times tables is where we have to have our estimation skills. So we'll start really simple. 35 into 168. I don't know my 35 times tables, do you? So we're going to have to estimate this. And I deliberately chose 35. So if we were to teach this from the very beginning, the first thing we teach our students is to round the divisor, correct? But what I want you to do is realize that estimation only starts with the rounding rules, all right? There has to be something else involved in our thought process here. So I want you to, the next thing I want you to realize is that the more you round, the less accurate your estimation. The more you round, the less accurate your estimation. So I deliberately chose the 5 here. Rounding rules tell me that I would round this up to 40. But that's a big round. From 35 to 40 is a relatively large round. So the more you round, the less accurate your estimation is going to be. All right, so you want to, as far as teaching is concerned, you want to train your students to be suspicious of their estimate and to realize that there's more to estimation than the rounding rules. Estimation begins, it only starts with, it begins with the rounding rules. So when you make a large round, specifically with 5, because it's right in the middle, or even with 4, and even sometimes with 6, you've done a lot of rounding. And so the more you round, the less accurate your estimation. Train your students to be suspicious of their estimate. What happens to the estimate if we round up? What's the danger to the quotient? If we round this up to 4 and we think 4 into 16, what's the danger with rounding up? What's the danger with the quotient?
The divisor will go into the dividend more times than...
Right, so then your estimate is too small. So when you round up, train your students to be suspicious. When you round up, especially when I do a larger rounding. Now if this was 39, Could I be more confident with using 4 in my estimation step? I can be, but this is 35. So the more you round, the less accurate your estimation is. So you train your students to be suspicious of when they do a big round. So if this is 35, I am rounding all the way up to 40. I am going to be in danger of my estimation being too small. So does 4 work? Does it work? It does. And so we're going to have to then, we need more than the rounding rules. Before we leave the rounding rules, what happens if I round down? If I round up, I have a danger of my estimate being too small. When I round down, I have the danger of the estimate being too large, correct? So the first thing that we do here is we train our students to be suspicious of their estimate when all they're doing is rounding. So that means we need another guideline. So our first guideline is, yes, we will round the divisor. But we need to train our students to be suspicious, especially when we do a larger round. So that means we need another guideline to play a role here. Is 4 going to work on my problem? Yes or no? Well, what I have to do then is I have to go to the next guideline, and I'm going to round the divisor, but then I'm also simultaneously going to consider the dividend. All right, I'm not just going to blindly round and then start my trial and error process. So I have to consider the dividend. All right, and what I mean by that is when I use the 4 in my estimation, I can balance the idea, okay, I did a lot of rounding here. Is my estimate too small because I rounded up? And the answer to that is consider the dividend. Does 4 go into 16 exactly? Yes. Since this is an exact division, I can be confident in it. So if my estimation, if my rounded up estimation goes into the dividend, pretty close, in this case it's exactly, then my estimation is probably going to work. So the first thing I do is I say, okay, rounding dictates that I go to 4. 4 goes into 16 exactly. I don't have to worry about my estimate being too small. 5 is not going to work. And I don't waste my time on the 5, okay? And the reason that I do that is because 4 goes into 16 exactly. I don't have to worry about this being too large. So I balance. And good students will do that automatically without thinking. But most 5th graders do not do that automatically without thinking. They round the divisor up and they just start dividing and then they erase. Okay, and we don't want them to be doing all this trial and error that makes the problems longer and tedious and more mistakes. So the first thing that I do is I begin with the rounding rules, but then I have to counterbalance that with the dividend. Okay, so I have to not just round and start and see how it works. I want to look ahead and consider the dividend. So I can work with the 4 here. So of course my first step in long division is to estimate, then I divide. From the very beginning, little side note here, from the very beginning with division, do not allow your students to be careless with their quotient. There's no decimal here, right? And so I'm not going to be doing more than one division here because it is a small dividend, but I don't just let them put that 4 wherever they want. So on the division step, I am not dividing 4 into 16, I'm actually dividing 35 into 168, and from the very beginning I require that my 4 is directly over the 8. Don't allow them to have the poor habit of just throwing the quotient wherever they want. It's got to go directly over the dividend to the place of the dividend to which they're dividing. And then I'm going to multiply. So I estimate, divide, multiply. 4 times 5 is 20, and I'm going to carry a 2. We'll be coming back to the carrying room in just a minute. I'm carrying a 2, so I get 140, and so my quotient is 4, remainder 28. All right, but what would happen if I had 35 into 188? So I estimated, divided, let me finish here, subtract. Compare, and I'm done in this case. 28 is smaller than 35. What would happen? What happens on this one? Remember, we need to keep this in tandem. I rounded up with my rounded up estimation, which goes into the dividend. How accurately? If the dividend were 188, how well does my 4 work now? It doesn't work, does it? Because 4 does not go into 18 exactly. It has that carrying room of 2, doesn't it? Do I need that much carrying room? I don't. So when my rounding up my estimate, I have to look at the estimate. Does the 4 go into the dividend accurately, or is there too much carrying room? There's too much carrying room here, because then when I do the 4, that estimate is way too small. But see, when my estimated divisor goes into the dividend exactly that time, I don't have to worry about it being too small. So yes, I round the divisor, but then I pay attention to what's happening when I actually do. I anticipate ahead of time. What's going to happen when I do 4 times 35? Okay? What's going to happen with 4 into 16? I don't have to worry about this estimate being too small. But when the dividend is this much bigger than the 16, my estimation does not go into it very accurately, then I'm going to have an estimation that is too small. So I want to teach my students to automatically pop this up to 5, because the dividend is too big for the quotient to be 4. Do you see what I'm saying? And this takes practice. All right? Hopefully several of you would have not used the 4. You would have immediately recognized that there's too much carrying room with 18. 4 is good. Or 4 is good with 16. 4 is not good here. So that's what I mean by looking ahead and considering the dividend. Does the estimated divisor go exactly into the dividend, or is there space there? Is there carrying room? 4 does not go into 18 exactly. There's too much space. 4 is a poor estimate. So there's more to estimation than just rounding the divisor and using your times tables. You have to take a look. You have to consider the dividend. All right, so what happens is when we are teaching rounding, we have to, or not rounding, when we're teaching estimation, there's more to it than just rounding and trial and error. We want to cut back on trial and error, and this takes practice, okay? 5th grade math, as I said, is very heavy in long division. What should you do almost every day? A long division problem as part of your board work. And every time you do the long division, you vocalize your thought processes. Okay? This is not a very large problem. All right, so I would teach the students to recognize that 4 is too small. And why is 4 too small? Because the dividend, okay? We're considering the dividend. The estimated divisor does not go into 18 exactly. There's carrying room there. There's an extra 2. I don't need 2. What am I going to carry? I'm only carrying a 2 to begin with. I certainly do not need 4. 4 is too big. Okay, so the first guideline is rounding. Yes, you will round the divisor according to the rounding rules, but train your students to be suspicious of just using the rounding rules. When should they be suspicious? When they've done a large round, like rounding up with the 5 or rounding down with a 4. So then the second step is, after rounding your divisor, you've got to teach your students to think, how much did I round? And remember the rule. The larger, the more you round, the less accurate your estimation. So when I round from 35 all the way up to 40, I'm going to be suspicious. And as soon as I'm suspicious, what do? I go to the dividend. I consider the dividend. A third step, a third guideline, not step, a third guideline is to anticipate the product. So as I'm estimating, my 2 main steps and my 2 main guidelines that I'm going to work with is the rounding rules and looking ahead to see what's in the dividend. But then this is where we're really looking ahead. Anticipate the product. Let me add a word here. Anticipate the actual product. In the case of this problem, I'm not anticipating 4 times 4 is 16. I'm anticipating what's 4 times 35. How much am I going to carry is the question here. Anticipate the actual problem. How much will be carried? Okay, so part of what we're trying to do with our 5th graders and our 6th graders is get them to engage their mind while they're dividing, not just estimate, divide, multiply, subtract, compare, bring down. Ever heard that during drill time? All right, that's rote memorization of steps. So we don't want them to be just blindly following the steps that they know they need to do. We want them to engage their mind while they're dividing. So it's not just using the rounding rules, that's only our starting point. Okay, so when we round, we think, how much did I round? And the more I round, the less accurate my estimation. I need to be suspicious of it. Unless it's 39 or 31. Then I can be a lot more confident when I've done very little rounding. You round a divisor from 31 down to 30, that's not a whole lot. Especially because 1 does not involve any carrying, does it? All right, but then when I'm rounding with 39, I have to pay attention to the carrying room, okay? How much will be carried? Is there enough carrying room in the divisor, all right? Or sorry, in the dividend. So these 2 steps kind of work together as well. I have to round the divisor, consider what's in the dividend, then anticipate the actual product. How much am I going to carry? In the case here, I am carrying what? 2. I'm still carrying 2. Not going to be enough, is it? So I am going to round my divisor. That's my starting point. But I've got to start engaging my mind when I am dividing, not just going through estimate, divide, multiply, subtract, compare, bring down. All right, so the next guideline is to anticipate the product. How much am I going to carry? And then the second question, remember, we're given guidelines, we're giving them questions to ask themselves. Okay, so yes, I'm rounding the divisor. And these are questions that I ask as we're doing problems together on the board. Show it to them, show it to them, show it to them. Practice it, practice it, practice it. You will help your intermediate student for the rest of their lives in math, for the rest of their academic life in math, if you teach them how to divide efficiently. And that's going to hinge on the estimation step. Okay, so rounding the divisor, what question should I ask? And I'm asking them out loud. I'm trying to train them how to think through a problem. And a lot of thinking is asking yourself questions. What question should we ask here? Get rid of this. What question should we be vocalizing and asking ourselves out loud as we teach the first thing? Yes?
Are you going to round up or down?
Okay. That's kind of in the process of rounding itself. How much did I round? Okay, remember, what if my divisor, I gave you the example of 35, what if my divisor is 39? Do I have to be suspicious of my estimate? What if my divisor was 31? So how much did I round? That's the first thing we want to start paying attention to. Yes, I'm going to round. Well, how much did I round? Because the more I round, the more suspicious I am of my estimate, because the less accurate my estimate will be. Okay, what question do I ask with the dividend? We had this one up already, kind of. Does the estimated product go into the dividend exactly, or is there room for carrying? So how does the estimate go in? How does the estimated divisor go into the dividend? Okay, so how accurate is this? Remember, 4 into 16 versus 4 into 18? The second one wasn't very accurate, was it? It did not go in, 4 does not go into 18 exactly. So then I know my estimate is too small, and I don't waste my time putting the 4 up in the quotient and doing the actual multiplication. I abandon the 4 and go straight to the 5. Okay? Is this foolproof? No, because there may be cases where it's really going to be close. So that doesn't mean that they'll never have to use a little bit of trial and error, but we want to cut down the trial and error to less and less, erase, 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 erase. Have you ever seen some primary students' math pages? They've erased it so many times they've, wore a hole through it and tore the paper and so forth. Maybe that's a little frustration as well, okay? But can you blame students for being frustrated? Okay? So, what question am I going to ask here? How much carrying, well, maybe the better way to phrase that would be, what am I going to carry? With the 35, what am I going to carry? What will be carried? Is there room for it? I'm just looking ahead. Okay, what am I going to be carrying? Is it going to fit? I'm thinking through. I need to engage my mind when I'm doing math. Okay, and the older the students become, the more they will have to engage their brain and the more they're going to resist it, especially at first. So if we give them give them some guidelines, give them some ideas, then we're going to have less and less frustration. Okay, so I'm giving them guidelines to follow rather than just steps. And I'm trying to help them think through the problem as they're dividing, so they don't have to erase. Try the 4, erase it. Try 3, erase it. Okay? Try 5. Okay? Sometimes the trial and error becomes out of hand for sure. Then there's a 4th guideline. Okay, so how much am I going to round? How does the estimated divisor go into the dividend? What will be carried? Is there room for that carry? Then a 4th guideline. A 4th guideline is going to be, this is my favorite one. It applies in more than this. Pay attention to the previous product. Pay attention. Pay attention. Pay attention to what you used before. Pay attention to the previous product in the case of division. You might use it again. Pay attention to the previous product. You might use it again. So the question here is, will blank work again? Will the 4 work again? Will 5 work again? If you paid attention to what you just used, it's going to give you a big clue to what you're going to use next, because you already have the product right there in front of you. You might need to go up 1, go down 1. So pay attention to the previous product. Pay attention to what you just used. Okay? You don't have to, some students will start completely over on each round of division. No, we want to see what we've already used. We want to look at the products we've already used so that we can quickly see what the next divisor is going to be. Okay? So we want to start anticipating what we're going to get, asking ourselves if we have carrying room, paying attention to what we just used. Will it work again, or should I go up 1 or down 1? So all these things can play a role into helping students divide more quickly and accurately without erasing a hole in their homework page. Okay, so you can see how these guidelines work. Let me do a few examples just to help you. Let's just do a few problems. I think a lot of problems with long division is this part right here. They're not paying attention to what they're doing. They're not engaging their mind. So you've got to start paying attention. Paying attention in all 3 regards. How much did I round? We need to pay attention to that. What's in the dividend? We need to pay attention to that. What's the product going to be when I use that in the quotient? What did I just use? A lot of it is we're not engaging our mind. And we just want to go through the motions and get our homework done. All right, so let's do a few problems. Let's try this one. Let's pop the divisor up to 3 digits and the dividend up to 6 digits. All right, what is the estimate? Is going to be 9, right? We're going to use 9 into 16 is going to be our actual first estimation, even though we're going to be dividing 884 out to 1,000. So this brings us to this guideline. Both of those guidelines. I am not wasting my time estimating on this at all. Well, maybe the consider the dividend is the guideline that applies. How many of you would waste your time with the 2? How about 5th graders? How about 6th graders? All right, I don't even need the estimate step. Sometimes with my bigger divisor, I can tell right away. Or what if I had this? 884 into, 900 and whatever. Do we need any estimation there? But my steps are estimate, divide, multiply, subtract. My first step is to round up the divisor. What a waste of time. We're not considering the dividend. So sometimes we don't even need an estimation. I may not know, or there's no such thing as 884 times tables, but I don't even need an estimate here. This is immediately going to go to 1, isn't it? So we've got to start paying attention to the problem, paying attention to what the divisor is, paying attention to what the dividend is, not rote estimate. There's no need to, you can round this up to 9 and see that 9 goes into 9 one time, but that's a waste of time. There's no need to estimate here. I can skip and go straight to the divide step. So all of these things can be taught, okay, and practiced. And then you're helping develop your students' thinking skills. That's why students do not like long division. They have to think about it, okay? When we're doing a lot of other math processes, we don't have to think about it. We've got our fact memorized, we just do our addition, we carry our number up, there's no thought involved really with long column addition, is there? Once we know the facts and the procedures, we just add and carry. There's no thought involved with subtraction. Once we know the procedure of borrowing and we know our subtraction facts, we don't have to engage our mind. We can start even doing it on autopilot. And autopilot's not going to work here because there's going to be so many different situations that come across. So in this case, I would just start my process. I'm just going to divide and multiply and subtract. Okay? Same thing here. I can see that there's no carrying room, is there? There's no carrying room for the 6. 8 goes into 16. This immediately is going to go to 1 as well. Not as obvious as this one, but needs to become more and more obvious that I can already tell what my first quotient's going to be. I am not even going to mess around with, I'm not wasting any brain power on rounding that up to 9 and thinking, okay, 9 into 16 goes one time. That's a waste of time. I can see immediately, I know that 8 times 2 is 16, and I see the 8 and the 4, I can see that there is no carrying room, is there? All right, so your students should never ever try 2. They shouldn't anyways, because they should be trained to go to 9, and not 16, 9 goes into 16 one time. So this is what I mean by we're using all 4 of these guidelines simultaneously. We're trying to think through the problem individually. So there are no steps. We have to look at the dividend, see if there's carrying room, see how accurately the estimated divisor or even the actual divisor goes in. We have to look and see what would the rounding rules do. Do I need the rounding rules? Well, yeah, most of the time I will use my rounding rules. But on this one, sometimes we're able to skip the estimate step on the first division. And the more we practice it and point it out, we say, oh, I don't need estimate right now. I'm going to go straight to division. I know that I cannot handle the 84. So I'm going to have to go to 1. So I multiply by 1. I subtract, compare. All right, and here's another place where the pay attention rule comes into play. That's kind of getting close there, isn't it? So what's my next digit going to be? Well, I'm going to bring down. All right, am I going to use 9 there? Too big, too small? Too big. So I'm going to go ahead on my next round. I will use my estimation step. I skipped it on the first one. I didn't need it, but most of the time I will need it. So 9 into 75 goes 8 times. Too much carrying or not enough carrying? Is 8 okay? Well, I know 9's too big, so 8's going to be I'm going to be pretty confident with it. Look at this other 8. What is 8 times 8? 64. I'm going to be carrying a 6, aren't I? So I don't have to worry. I'm carrying 6. Is going to be my carry, so I don't have to worry that 9 doesn't go into 75 exactly. I know I'm going to be carrying a 6, and I know that I'm going to be pretty close. I'm going to go ahead and 8 will work. Bring down my 0. 9 into 44. We need to cover this. How many times is 9 go into 44? 4 times. But how much carrying room is there? A whole lot. So in this case, I am not going to do 9 times 4 is 36. I am not wasting my time with the 4. Why not? When I round up to 9, 9 does not go into 44 very accurately, does it? So I'm going to abandon the 4 and skip to the 5. And what's going to happen if I keep going over the division with my students and help them to see those things? Are all of them going to improve their estimation? Well, a little bit, but there'll be a few of them that really pick up on it. All right, so think about this. If you ever have the thought, oh, I wish somebody would have showed me that, or I wish somebody would have explained that relationship to me, that makes everything so much easier. So there's a lot more to estimation than to just use the rounding rules. Did the rounding rule work here? No, it doesn't. Did it work here? Yes. What's the difference? The difference is considering the dividend. Okay? Does it go in, does the estimated divisor go into the dividend? Exactly. In this case, it doesn't, so I'm very suspicious of 4, and I'm going to skip right to the 5. So we need to practice our long division, and that's more than just having students go up to the board and do it on their own. We start helping them think through the problem and getting them to pay attention. Sometimes pay attention has the connotation in my mind of engaging their mind, not just going through the motions of doing it. Okay? So, let's do a couple other problems. Well, you can see the 4 is too small. But I want to establish these ideas in their mind, get them into the habit of questioning their estimate, paying attention to what they just used. Okay? Let's see. Let's do this problem. Let's say my divisor is 1, 2, 3, and my dividend is 84,378. All right, going based on the rounding rules, what am I doing? When I use the rounding rules, 23 is not big enough to round this up to 200, is it? So I'm going to round down, and I have to be careful that my estimate isn't too large because I will be carrying, but not so much with a 2. So when I first do this, 1 goes into 8 how many times? 8? Am I going to use 8? Why not? Well, you have 5th graders that do it. Sure you will. what am I actually going to use here? I'm not even going to use 7. Okay, I am going to use, 1 goes into, the other thing that I can do I have to round this down to 1? How about I use 12? I know my 12 times tables. You do not have to just automatically round to the farthest digit. Round to something. A lot of times when you're dealing with estimation, with division, you'll use what some textbooks, in particular it's the Bob Jones textbooks, calls compatible numbers. All right, so I know my 12 times tables is going to make, you saw how inaccurate using 1 is. So I don't have to just always round the first digit. I might be able to round to something that I am familiar with. I might be able to round to 25 and think in terms of quarters and dollars and cents. All right, I don't have to round to the first digit. I can round to something that'll work. Now, how many times does 12 go into 84? 7. Am I happy with 7? No. Why am I not happy with 7? There's no what? There's no carrying room. And when I have a 7, I have a 3 here, I'm going to be carrying 2, and I have absolutely no carrying room. That's why we consider the dividend. That's why we anticipate, what am I going to carry? There is no carrying room. I see that 12 goes into 84 exactly 7 times, and so I'm not using 12. I have that 3 that I have to carry for, so I'm going to pop down to 6. Okay, so there's lots of things I can teach my students to think about. I don't want them to just rotely round. This works much better with 12. And I still have to consider the fact that 12 goes into 84 exactly 7 times, so I'm going to not use the 7 because I'm paying attention to what's in the dividend and the fact that I'm going to have to carry a 2. At least with the 6, I'm only going to be carrying 1. So 6 times 3 is 18, 6 times 2 is 12, and so I'm going to be okay with that. And that'll give me 105. Okay? And I'm still also paying attention to not only do I have to compare the 105 and see that it's okay. Comparing is more than just seeing, oh, I worked, it's okay. I need to pay attention what's going to be coming next. I'm going to be anticipating the next product. So I'll bring down my 7. How many times does 12 go into 105? 8 times. Is there carrying room for an 8? Yeah, I'm only going to carry 2. 2 times 8 is 24, so I'm going to go with 8. 8 times 3 is 24, 17, 974. Oops. 24, carry to 2. So then when I subtract, I get 73 and bring down my 8. And I need to pay attention with the fact that I've already used that I am done. So I'm going to use the 6 again. Oh, look, yay, I got something easy. I've already had 738 when I multiplied by the 6. So there's all kinds of things to do. All right, we're going to use the rounding rules, but then we have to consider what's in the dividend. How accurate does, or how closely does my estimated divisor or my actual divisor go into that dividend? Is there carrying room? What am I going to carry? Is there enough carrying room? And then pay attention to different other aspects of it. Do I even need to estimate? Or can I see it even right off the bat? Maybe it only go in one time. It'll be something more obvious. So there's a lot of things to do. As I see a lot of different students, whether it's college students or high school students or junior high students, I'm seeing a lot of lack of division skills. Why? Wasn't taught, wasn't practiced. We endured our long division, we got through it, we finished it, but we really didn't acquire that skill. So remember, estimation is not just a procedure. It involves thinking through. It's a thought process. We have to help our students, help them think through each individual problem. We can do this with more guidelines that play different roles, but we also should help them by giving them questions to ask themselves, okay? Questions like, how many times does 12 go into 84, and is there any carrying room? Questions like, what am I going to carry? Another question, have I used this before? Will 6 work again? So we have to be actively engaged in what we're doing, and then we have to practice it. And I'm also not just going to show it to them one time. I'm going to try to practice it a couple of times a week, maybe daily when I'm in the whole number section. Daily, then I have to throw in the decimal curveball. Decimal division becomes very difficult because I can't even do whole number division efficiently. I'm constantly doing the trial and error and erasing on my page and so forth. Okay, so have a goal to really teach division. If you can instill estimation skills, you're going to make the long division that much easier for them. Then when we get to the decimal math, we can concentrate on the decimal placement and putting the decimal up in the quotient properly and putting the quotient exactly where it belongs. We don't have to then struggle with the actual division. So I think the division is very much lacking. Long division skills are lacking. I've noticed on math placement tests, I noticed when I get my new crop of 7th graders, I noticed 2 main areas that students are lacking in basic math skills. First, well actually 3, but basic math skills of fraction math, in particular addition, and then the other problem is long division. And it really doesn't matter if it's whole number long division or decimal long division. And then when we are doing the decimal long division, we keep tripping over the actual division. And we can't concentrate on getting that decimal point correct. Then it gets worse when we get to the percent section. Not only now do I have to understand the percents and how they work, I also keep missing problems because my long division skills are not there. And my decimal skills are not there. It's like a snowball, has a snowball effect. I really never got the long division, then I really didn't get the decimal, then what happens with the percent math? It's a complete disaster. All right, so have a goal to teach your upper elementary students. 5th grade is where it really starts, but even starting with the 4th grade, teach them how to think through their division problem. Give them these guidelines or make up your own. Give your thought processes. Don't teach procedure only. Get them to start thinking, and how we do that is we ask questions. You ask them, and then you get them to ask them. All right, so it's more to teaching math than just showing students how to do a problem. Try to teach them how to think problems through. Because then we come across that 3rd area that I just thought of, and that's application. Okay, application shows that we do not want to engage our mind. We want to get our homework done. And you're going to be battling that all the time with teaching, and especially in math class. We don't care if we can do it, we just want to get it done. And if you're in our school, you want to get it done and you want to get it above 78. Because that's C-, and our students have to get the D's and F's signed. And many students are happy that they got the 78. All right, so estimation and the importance of division. So this is something that can be practiced. And there's all kinds of different circumstances that'll come up. I just showed you a few. All right, we are done for today. So then on Friday, we're going to start working more with percents and percent applications for your own skills. And that's when your Chapter 5 homework is due. So bring your textbook on Friday. We'll see you then.